Okay, state the quadrants. So we're looking for quadrant 1, 2, 3, or 4, where theta lies if we know that tangent is negative, less than 0, and cosine is negative, less than 0. So I'm going to start with the tangent part first. Tangent is negative in quadrants 2 and 4. So it can't be in 1 or 3. Cosine is negative in quadrants 2 and 3, so we can't be in quadrants 1 or 4. So then based on this, if you were to overlap them, we would end up with the second quadrant being our winning quadrant. Okay? The other way you can think about it too is that once you've eliminated quadrants 1 and 3 for tangent, you can just ask yourself, out of quadrants 2 and 4, where is cosine going to be negative? Remember, all things are positive in the first quadrant. Sine and cosecant are positive in the second quadrant. Tangent and cotangent are positive in the third quadrant. Cosine and secant are positive in the fourth quadrant. And it has to do with your x's and y values. Determine the following information given that theta falls between x-axis and the terminal side and goes through the point negative 5, 12. So the first thing I'm going to do is I'm going to draw negative 5, negative 12. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's some tick marks in there. So negative 5, negative 12. So my terminal side of my ray, of my angle, goes through that point, negative 5, negative 12. So I'm going to draw my reference triangle. Reference triangle draws to the x-axis. The angle itself is at the origin. So here's my reference angle. Right angle here. This side is negative 12, and this side is negative 5 because of plotting the coordinate point, negative 5, negative 12. Well, which quadrant must theta lie in? That's going to be in quadrant 3. What is the cosecant of theta? Well, the cosecant is going to be the flip of sine, and sine is the so. So cosecant is going to be the hypotenuse over the opposite. So cosecant of theta is the hypotenuse over, well, from this angle, my opposite side is negative 12, which means I just need to find this mystery hypotenuse. So I'm going to use the Pythagorean theorem, negative 5, which is a leg squared, plus negative 12, which is a leg squared, equals my hypotenuse squared. I'm going to end up with 169 equals h squared, which means that h itself is 13. There's a 5, 12, 13 triangle out there from your geometry Pythagorean triples. Okay, moving on. Given that tangent of theta is negative, right, negative 5/6, and cosine is greater than 0, so cosine has to be positive, find all 6 trig functions. Okay, well, let's think about this first. Tangent has to be negative, which means I could be in quadrant 2 or 4. Cosine has to be positive, which means I could be in quadrant 1 or 4. Which quadrant do I have to be in? Quadrant 4. So I'm going to draw my triangle in quadrant 4 to the x-axis coming from the origin, just like I usually do. Because I'm given tangent, tangent is the opposite over the adjacent, and then I need to figure out which one of these gets my negative sign. Well, if I were to plot this point down here, I would have traveled positive 6 and negative 5. So I get a negative 5 on that side. Finding all 6 trig functions. So first you got to make sure you know what your 6 trig functions are. There's sine, there's cosine, there's tangent, there is cosecant, there is secant, and there is cotangent. And I've written them right next to their reciprocals, so hopefully they're not too bad to find. First thing, tangents I can get right away. I already know the tangent of theta was negative 5/6. That was given to me, which means cotangent is negative 6/5, because you just flip your fraction. In order to find sine and cosine, and thus cosecant and secant, I need to know what my hypotenuse is. So I'm going to have 6 squared plus negative 5 squared equals my hypotenuse squared. Based on this, I end up with 61 is equal to h squared, which means that h is equal to the square root of 61. I sense some rationalizing happening soon. Square root of 61. So the sine is going to be my opposite over my hypotenuse. I'm going to leave it like this. I'll come back and simplify in just a second. Cosine is going to be my adjacent over my hypotenuse. And here's why I'm going to hold off on simplifying. Because cosecant, I just need to flip this. And so it's pretty easy to flip when it's written pre-rationalization, if you will. Okay? So hypotenuse over opposite for cosecant, hypotenuse over adjacent for secant. For these ones, I need to rationalize, so I'm going to multiply by root 61 over root 61. And so final answer, negative 5 root 61 over 61. And in this case, 6 root 61 over 61. Yes, you will have to simplify and rationalize your answers, right? So make sure you've practiced that skill from many moons ago. All right, unit circle time. Use the unit circle to evaluate the following. So we're looking to evaluate trig functions. Notice that I've been provided an angle. In each one of these, I am given the angle, which is going to tell me exactly where to look. I just need to remember then that if I'm looking for the sine of that angle, that's y. The cosine of the angle is x. The tangent of the angle will be y divided by x. The cotangent of the angle will be x divided by y. The cosecant of the angle will be 1 over y, because it's the hypotenuse, which is 1 in the unit circle, divided by the sine. And then last one, what am I missing? Secant. Secant of theta is going to be 1 over x. Okay, so 5 pi over 6. 5 pi over 6 has a reference angle of 6 because of the denominator. 5 pi over 6, I'm looking for a yellow sticker. It's right here. I'm supposed to read the cosine, which is the x value, according to my list. The x value is negative square root of 3 over 2. Part B, finding the tangent of 11 pi over 6. Well, 11 pi over 6 is, again, a reference angle of pi over 6. Here it is. Tangent, I'm supposed to take the y value and divide it by the x value. So my y value is negative 1/2. Come on, pen. Negative 1/2. And my x value is the square root of 3 over 2. When you divide a fraction, it's really the same thing as multiplying by the reciprocal. So I end up with negative 1 over the square root of 3. Because my 2's cancel out. Rationalize that, I get negative square root of 3 over 3. Okay. Cosecant of 7 pi over 4. So 7 pi over 4 is more than 4 pi over 4. It's right here, hiding. 7 pi over 4. And I want the cosecant, which is 1 over the y value. 1 over the y value, which is really just flipping your sine value. When you rationalize this, square root of 2 over the square root of 2, you end up with negative square root of 2, okay? Because this across the top will be negative 2 root 2. On the bottom, you get 2. These cancel out. Negative root 2 is your answer. Cotangent of 225. 225 down here in the third quadrant. 225 cotangent is supposed to be the x divided by the y. Well, x and y at this moment are exactly the same in value and in directions. I'm going to take negative root 2 over 2 and divide it by itself. Negative root 2 over 2. Any number divided by itself is exactly 1. And your double negatives do cancel out. Oh, this one was my 1 over here in green. Okay, again there, sine of negative 8/3 pi. Well, negative 8/3 pi, this would have been backwards 1/3, because the reference angle, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3, 8/3. So I'm looking to be coterminal with 4 pi over 3. Sine is supposed to be reading the y value, and the y value is negative root 3 over 2. So make sure you understand for that one which part, if any, is tripping you up. Maybe you got that just fine, you're good. But is it the counting of negative 8 pi over 3 that's hard? Or is it remember reading the negative root 3 over 2, the y value? That's hard. Okay, so make sure you're kind of breaking those two things up in your head. One of them is getting to the angle, and one of them is reading a coordinate pair. 270. 270 is down here at the bottom of my circle. Secant is supposed to be 1 over the x value. The x value is 0, so I get 1 over 0. We don't know how to divide by 0 in mathematics, so we say that the secant of 270 is undefined. Okay, that is an undefined value. We don't know what 1 divided by 0 is. So those were, here's the angle, find the trig ratio. If you need a refresher on that, that's going to be video 3.8. Okay? Use the unit circle this time to find the angles. So this time I'm giving you a ratio and I want to find the angles. Those angles have to be between 0 and 2 pi. So we're looking one time around the circle, and they have to be in radians. So cosine of what angle gets you negative root 2 over 2? So really you're saying the x value at theta is negative square root of 2 over 2. Well, cosine is negative in the second quadrant and the third quadrant. So my angles are 3 pi over 4 and 5 pi over 4. Okay. Sine of theta being 1/2, you are saying the y value at theta is positive 1/2. Well, where is sine positive? That's going to be in quadrants 1 and 2. Positive 1/2. My angles are going to be 5 pi over 6 and pi over 6. Notice that they have the same reference angle, right? Because reference angle creates the size or the ratio of the sides of the triangle. Tangent gets a little bit trickier. Tangent being negative root 3 means that when you take the y value divided by the x value, you have to end up with a root 3. Okay, negative root 3, even more so. Well, tangent's negative in quadrant 2 and 4. So I definitely know I'm looking here or here. There's going to be two different ways that I could have ended up with a square root of 3. Either I took the reference angle and these coordinates, or the reference angle and these coordinates. But let's think about what tangent means. Tangent means opposite over adjacent. So the square root of 3 is going to be when you take the bigger opposite and divide it by the smaller adjacent, because then this ends up multiplying by a reciprocal, 2's cancel. So we want this up here where our y is taller. Square root of 3 is tall, right? So I'm going to end up at, I was color coding things nicely. It's this coordinate pair and this coordinate pair. So 2 pi over 3 and 5 pi over 3. Okay. Last one, secant of theta. The easiest way to think about secant is instead to say, well, let's evaluate the cosine. I already used purple. Cosine of theta would be equal to negative 1 over 2, right? You flip it. So where is the x value? Negative 1/2. X is negative 1/2 right here and right here. So 2 pi over 3 and 4 pi over 3. Come on. 2 pi over 3 and 4 pi over 3. Real quick, I want to talk about tangents. Your tangent values in a quadrant, do not add these to your plate. But they go 0, square root of 3 over 3, 1, and then the square root of 3, and then undefined. So the bigger your opposite side, the bigger your tangent, which is why the square root of 3 happens, the bigger one, not the square root of 3 divided by 3. This one will always happen at the 60-degree reference angles, whereas the root 3 over 3 will always happen at the 30-degree reference angles because of how you divide y by x. That's it. You did it.